Well, welcome back, everyone. I know it's been a little while, but we're going to get started on another project. For anyone that's new, my name is Mike. This is my channel, Build It or Buy It, where I design, fabricate, and build different things, and then I evaluate whether I should have just bought it or purchased it versus building it. So stick around, and I'll go over why this stuff and this stuff is going to be in this video and what it has to do with Build It or Buy It. Okay, so what I got going on in this project or in this episode, I'm hoping it'll maybe just be one, maybe two at the most, is to get a trolling motor, this trolling motor here, installed on this boat here. So this is, you might ask, how's that going to be a build it project? What it has to do with is how I'm going to mount the engine itself. And there are a number of, this will be kind of a hybrid because it's a little bit of buying and building. There are some components out there. Let me grab it here. There are some items out there that you can buy that basically I probably couldn't build as inexpensively. So this is one. This is, I guess you could call it it's kind of a jack plate type thing, just all manual though, that you can mount an outboard to, small outboard, and mount that to the back of the boat, and then that lets you raise and lower the trolling motor. I don't have the exact to the penny cost, but I found that on Amazon, and by the way, it came with this mounting plate there that I already have on the trolling motor. I think it was like $72, $73, something like that on Amazon. It's all stainless hardware. As you can see here, it's kind of got some adjustable stops, a spring that helps you lift the weight. Something like that. I wouldn't have been able to build it for that. So I went ahead and purchased that. But I think I may not end up using that, and I'll go over that in a minute because of the distance it sticks back. So if a person was to use that, if you had a kind of a more of a traditional ski boat with a flat transom, it would work fine because it's designed to where this would bolt onto the vertical portion of the transom. Then that allows this to go up and down. You mount the motor on there, pretty straightforward. Well, obviously that doesn't work so well with a ski boat. This surface in here is fairly flat, but let me scoot you in here a little closer. This surface is fairly flat, but as you can see, it doesn't stick out anywhere near enough, far enough to hang the motor off it. So we end up having to come back. Here somewhere. Well, because this has a swim platform on it, there's nothing there to mount it to. The only flat surface would be clear underneath the swim platform, which that doesn't work either. So that's where the build it aspect comes in. So I need to come up with a way to mount that looks halfway decent, isn't some cobbled together contraption that's on the swim platform. So kind of when I'm going to build stuff like that, I kind of try to mock it up as best I can just to get a feel for what I'm going to need to do. And I didn't video any of that. I didn't think I'd actually even do an episode on this, but given there was some fabrication involved, I decided to go ahead and do it. So I'll just kind of give you a recap of what I did to get to the point that I'm at now. So I moved the boat outside. I just used the tractor to suspend the motor, which back to the gantry crane. If I had that done, that would have been a little bit easier. So that'll probably be a winter project. So I pulled the boat out, hung the outboard from the tractor. So basically I hung the outboard in this spot right here. I'm going to put it on this side versus this side because the swim ladder's there. So it's going to go over here on this side. So I hung the motor at the height that I wanted, taking into account the extending the line of the hull, the bottom of the hull out to the cavitation plate on the motor. So this area right here to make sure there's enough prop in the water. There's kind of two schools of thought on that. since it is a trolling motor, you don't really have to consider or take into account the boat being on planes. So it's not uncommon to have a trolling motor where the propeller is actually higher up out of the water. Basically, the propeller could be in this area, not actually below the bottom of the hull. If you're on plane, that wouldn't work because obviously then the prop would be completely out of the water when you're on plane. But with a trolling motor, you're never going to be on plane. So that prop would still be submerged and still propel the boat. Some would argue that it's not going to work as well because there's going to be that kind of a cavitation area of the water swirling around behind the back of the hull. I had a pretty good sized fishing boat that had a trolling motor on it. That's the way it was mounted. It worked just fine. The only time there was a little bit of a performance issue was if you were trying to back up, because then as the prop is in reverse and you're thrusting that water backwards towards the boat, if the prop's below the hull, it doesn't hit anything. The water, and you back up pretty well. If the prop's up above that plane of the bottom of the hull, then the prop wash actually pushes against the transom. So the boat still backs up. It just that maybe the performance is a little less than what it would be with the prop below the bottom of the hull line. But realistically, with a trolling motor, you're not doing a lot of backing up anyway. So I kind of split the difference on this. This will stick a little bit below the bottom plane of the hull, but not by a lot. And what that lets me do is the motor's like any typical outboard. It has a hinge point and a latch, so you can actually fold the lower unit up. So I'd rather try to utilize that feature instead of using this mount, because this mount ended up, by the time I mocked this up, as I was saying, by the time I put the motor back there, held it in the position I wanted, came up with a mounting bracket. I'll switch you here so you can kind of see how far this sticks out. This was going to stick out a really long ways, then you've got the motor back here. So when it comes to wanting to put the engine in and out of gear or raise it up out of the water, things like that, you would have been really having to lean a long ways out. So I don't think I'm going to even use that, or I'm going to attempt to not even use that. And I'm just going to, that's why I've got the hard rubber mount attached to the motor. So I held it up to the back of the boat with that mount on it. And I think I can make everything work. Geometry-wise, that gets the motor considerably closer, so it's much easier to reach the controls. I probably will set it up with a remote steer on it, but that'll be for another project. So anyway, that's kind of the setup of where we're at. And how did I determine what the bracket was going to look like? Let me grab a piece of paper here. So my preferred method when I do stuff like this is, as I mentioned, I put the motor where I needed to be in space, give or take a little bit. And then I just kind of start taking some measurements. Sometimes I'll use cardboard, sometimes I'll use paper. And so in this case, I just cut out some pieces of paper, kind of made a rough sketch of how I wanted it to fit and what I wanted it to look like. Then I went in and transferred that into CAD, so it'll be a little bit more accurate. Print those out full size, cut those out of just paper, come out and hold them up just to kind of see if I need to do any fine tuning. So that's what I've got here. This was just a paper sheet that after I drew it up in CAD, printed it out. So I will scoot you kind of back to the side so you can see how this fits here on the hull. So the height of the motor, the one good thing about it is that the mounting bracket won't be sticking above the swim deck. It just worked out well to where the mount will be kind of almost level actually with the swim platform. So if a person still wants to walk back here, it's not going to be a problem. So this basically goes on here like this. It just sits up here. It matches the curvature of the hull. It has this clearance notch here for the rub rail. So this is going to sit on here. That sits on there like that. That creates this, if I can hold it with both hands, that creates this flat plate here that then allows me to attach the rubber block. I did, when I kind of decided to go this route, I did stay with the same. Fortunately, that rubber block has the same exact bolt pattern and spacing as this. So even if for some reason that bolting the rubber directly to this doesn't work for some reason, that trapezoidal mount, this mount here, will actually bolt into the same set of bolt holes, so I could always revert back to using that if I need to. So, but I don't think I will. So I think everything's gonna work out fine. So once I kind of do it in paper, then let me grab the next thing I typically do. So then after that paper pattern, and sometimes depending on what I'm building, I may not go any farther than the paper pattern. If it's just a matter of figuring out a hole placement or something like that, a lot of times that's how the farther I'll go. But in this case, since there's a lot of fitment and clearance potential pitfalls, I'll usually go a little bit farther. So in this case, I just transferred that paper pattern to some cardboard to fold it up. And let me grab some tape here and I'll show you how that plays out. So what I basically did after that was, after I had it in the cardboard, I'll just give you a quick example here. I just set it up in here in the general location where I was going to put it, you know, and put enough tape on it to hold it pretty firmly in place. That's just an example. I had it taped up pretty good, taped on the sides, so I actually could push on that cardboard pretty good. So then again, I hung the motor from the tractor, brought it up there, played around with the heights a little bit to make sure I was happy with it, and I was. So then that kind of gives me the confidence that before I start making the part out of metal, that it's going to work out. Cardboard I use sometimes. Sometimes I would make it out of some thinner sheet metal. Sometimes wood. It just depends on the situation. So I made that mock-up piece out of cardboard. And then the next step would be to transfer that to whatever I'm going to use for the permanent mount. In boating world, stainless is kind of the go-to, but stainless is a little trickier to work with. It's just harder to drill. I don't like stainless at all. It's just a kind of a pain in the butt. So I chose to go to aluminum, and I'll either powder coat it or I'll put probably a catalyzed paint on it so it'll still hold up. This is a freshwater used boat, so it's not going to be in the salt water. So even if the paint would be compromised at some point, it's not going to hurt the aluminum any. And aluminum is much easier to work with, at least when it comes to bending it and those types of things. So I certainly could have cut. I have some. I decided to go with eighth inch 125 thousandths aluminum, and I have some here. And I could have made the part. It's not that big a deal to cut it out and drill some holes. But I ran across the resource a while back that I've used a couple times that I'll talk about, and they don't sponsor me. I don't get any kind of a discount. I just happen to like them because they have a good service and a reasonable price. So I'll talk about that a little bit. And that company is called Send Cut Send. And basically what they do is they will cut out whatever piece you need, whatever quantity you want, out of whatever material you want, wood, copper, stainless, aluminum, plastics, it doesn't really matter, to your design specifications. If I might insert it in here, show you their website a little bit, but it's just super easy to do. If you happen to have a CAD drawing, there's I think 5 different file formats that they can work with. DXF, I can't remember all of them. I'll maybe try to insert that and show it. So you can draw the part yourself, and when you go to their website, you literally just drag and drop that file onto the page. It imports it quickly. It shows you a preview picture of what you've drawn just to make sure that it looks okay. It's like 3 more clicks and you're done. You click on what material you want to use. It gives you a drop down, shows you all the different dimensions or thicknesses of the materials, what the alloys are. You accept that, which one you want. You can opt for deburring afterwards. They do dimpling, a lot of other different things. So you can pick different operations, but if you, in the case of this, if you just simply want a piece cut out, it's like I said, it's like 3 clicks. It shows you an individual price to buy one, and then there's a significant discount if you buy multiples. Sometimes the price will be cut in half. So that's what I chose to use to get that piece cut out of aluminum. One, it exactly matches my design. So that's what was in the thumbnail, and that's this piece here out of aluminum. I'll try to get you in here really close. They have their cutting operations are, I think they have CNC routing, they have plasma, laser, and water jet. So depending on what material you're going to have cut, what thickness it is, they'll pick which cutting operation they're going to use. But the part comes this way. I mean, the edges, let me try to get an edge here across it, show you just some different angles. It's very, very nice work. And again, it's to CNC thousandths of an inch level. I'll cover what the cost is on this when I kind of do the wrap up. So that's the next step. I've got the plate here. I'll get that bent up, and for the mounting of it, obviously it's a fiberglass boat. I want to try to make it as clean as possible. So this, it's easier to show on this plate. So I will have paper, actually I'll use the cardboard template. And I'll show this when I get to it. So for this piece that sits on here, there's going to be some aluminum flat pieces that come up here. They'll come in here and stiffen this up. They'll be countersunk, and then some nice overhead stainless steel hardware will screw down into the top of the swim platform. So there'll be a little bump up here, but it'll all be smooth edge. So again, if you're walking out, you don't have to worry about tripping over anything. And then on its lower level, above the water line, even if it was below the water line, it would be fine because it'll be sealed. Same thing. I'll have a piece of aluminum strap that's bent to this curve, and there'll be some additional stainless steel hardware there. So to make sure that the fit is really nice, I'll bend those pieces up, get them to where they're fitting really well, and then I'll hold the bracket up there and I'll probably put down some stainless steel tape to protect it and do a quick spot weld on those so that they're held in the exact correct position. Then I'll pull it off and weld the whole thing up, and then we'll get it mounted. So that's kind of the next step. I haven't got the piece bent up, so I'll get to that and bring you back when I do that. But before I do that, I do want to give a shout out to one of my viewers. One of my viewers, I learned the other day that she'll go to her grandpa, who she calls Papa, and say, Papa, can we watch one of Uncle Mike's YouTube videos? So I appreciate that a young lady by the name of Lucy likes to watch my videos. So I just wanted to say, hi, Lucy. Maybe one of these times we'll talk with your parents. Maybe there's one of the times you can do a guest appearance and you can help me on one of my videos. So stand by here and I'll get this piece bent up, and then we will move on to getting it mounted. The last time you saw the piece, it was flat. Now, as you can see, it has been broke in 2 spots, bent in 2 spots to fit. So it's going to go just like when I was showing the pattern. It goes down here. I'll scoot you in here a little closer to show you what I've got going on. So as you can see here, I've got the aluminum. I made some, as I mentioned, some flat pieces of aluminum. It's about 1/4 inch thick, 1 1/8 or so wide. I bent those to match the curvature of the hole. And then up here on top, I've got 2 more pieces. They're not temporarily taped in place yet. Let me get the tape off of this one so you can kind of see what they look like. And the way they work is, once I get this piece up here where it belongs, those will just lay across there like that, and that'll give me the 3 bolting spots right here, as well as the 3 spots down here. So that'll be a total of 6 stainless steel screws attached into the fiberglass, which should be more than sufficient. That's only a 7.5 horse trolling motor, so there won't be a whole lot of push on that. What I'm using for hardware is these oval head. They're countersunk, but an oval head screw has, and you can tell there has a little bit of an arc stop, so they're a little bit nicer kind of a finish instead of just a flat countersunk screw. Stainless steel, so they won't rust. The aluminum won't rust. So I've got those lower brackets taped right where they need to be. I did drill a 16th inch hole in all of the places where a screw will go. So that way, before I drill the screw out to the hole out to the bigger size and countersink it, I can tape all the mounting brackets in place and then use that 16th inch hole as the drill guide. So I'll come along and drill each one of those. I'll set you back here out of the way and get that done. Then I can go ahead and drill those holes out to the correct diameter and put the countersink in them. So once I have that done, then I'm just basically going to hold it up in their place. I've got some heavy foil tape on the hole to protect the fiberglass. I'm not going to completely weld them in place. Obviously, that would be very, very hard on the fiberglass. So I'll just do some tack welds to hold it in place. I'll pull it off and weld it up and hope it doesn't pull too much from the heat. So let's get those transfer holes done. So let me get these over and I'll get them drilled, or I'll get set up on the drill press and show you at least one of those holes, and then I'll get them all drilled. Okay, so I've got a countersink bit here, multi-fluted one that's about just a little bit larger diameter than the head of the screw. And if you've watched my channel before, you see me back here at my, this has got to be, I imagine made in the 40s, this Delta, back when Delta, Rockwell, and Milwaukee were all the same company. There's the fancier drill press over there. But this is kind of my favorite one for these types of things. So because this is barely 1/4 inch thick, I was hoping that as I countersunk it that it would open the hole up enough to where the screw would drop through, but it's not going to. So let me throw another bit in here real quick and open that hole up so I can test fit the screw. All right, so I opened that screw up. Show you how it fits here. I'll probably go just a little bit deeper, so I'll get you a better angle. Just sticks up just a hair. I'm going to come down just a tad bit more and then do the other 3. That's kind of what I'm looking for right there. All right, you don't probably want to, probably a little boring to see me do that many more again, so I will get those all drilled and then I'll bring you back and we will get it taped in place and see what it looks like before I tack it up. Forgot to turn the camera on, got the first one installed, so we'll get the second one installed here. And clip you here so you can get a close up. All those fit. I'll take the tape out after I get things tack welded and So that fits just about the way I want it. You can kind of see there. I'll tack in here, and so let me get these upper ones taped in place, and I'll just basically I'll show you that it'll be the same thing. Drill 3 holes, attach those down, then I'll hold the piece up there and tack it in place. So I'll be right back. Just got it pasted in place, and you can see this is what I was talking about. I leave a little bit of a ledge on both sides, and that will be a good spot to put a nice little fillet in there. So I'm going to transfer those holes just like I did on the other one. Yeah, maybe. Okie doke. So that's in place. Now it's just a matter of putting a couple tacks on there. I'm going to go in and grab a bite to eat, and then I'll come back out, set the welder up, and get them tacked. Okay, so let's get this thing tacked up here. When I got the bigger Miller welder, came in kind of handy, because then I was able to leave my other 175 amp machine set up with the aluminum spool going on, just set up permanently, so it comes in handy. And so I'm going to use the wire feed to get the tacks done. I can get in and out really quick, and so that doesn't allow for a lot of time for the heat to transfer through the aluminum and get into the fiberglass. And then I'll get it over on the welding bench and finish welding it up via TIG. Okay, so there it is. I'll get set up here to weld it permanent and be right back. Okay, so I've got the welder set up here. I'm just gonna run some beads down in that area. I don't have a easy way to put the camera inside of a spare helmet, so you probably won't see anything other than bright light, but I'll show you the end results. Got a little warm and melted through it there at the very end, but I'm a little out of practice. I don't do nearly as much TIG stuff as I used to, so I'm a little bit out of practice, but they don't look too bad. So I'll finish getting the rest of these knocked out and then show you the finished product. Okay, so that went well. Fully welded on both sides of each one of the seam. I know I got pretty good penetration, because you can see on this one that I welded first, and that fillet was pretty much level. You can see these spots here. That's basically melt through from the other side. So I know I got a good penetrating weld. So I threw it in the sandblast cabinet, sandblasted it to give a little bit of etch, and I'll throw a couple coats of paint on it, and then I'll bring you right back and we'll bolt it on and see what it looks like. All right, so got the bracket all painted. I got kind of lucky and found just at the local hardware store a can of paint that showed it was just slightly off-white, which the gel coat is. So so that's the color I painted it. I'll show you here in a second. The other thing I did, as you can see here, is that I taped off. I temporarily screwed it up there and then taped off really close to the bracket. So that way I can put a little bit of sealant in the screw holes to keep keep any water from ever getting in there, and around the perimeter a little bit, so when I bolt it down, that'll squeeze out a little bit, and then instead of trying to clean up that squeeze out, I can just pull the blue tape off, and that'll leave a nice crisp edge. So let me get that installed, and I will show you what the finished product looks like. All right, so that is the final fit. You can see the color matches surprisingly close. The tape didn't clean the ceiling up quite as good as I hoped, so I'll just do a little bit of cleanup on that. And then I'll get the outboard mounting bracket mounted and show you the final end product. While I'm tightening this up, I guess we can talk real quickly about the build it or buy it aspect. And in this case, kind of regardless of cost, build it was a better option. If you recall, this jack plate here I bought, so this would have worked. I could have made it work, but you can envision how much farther that would have stuck out and in the black. So I don't think it's a good option. Would it have worked? Sure. So because I don't really like that option, I promise you nobody makes any kind of a mount that would fit this boat exactly. So that comes down to basically building it is the only option. So that jack plate, I could return that, but that jack plate, I think I said was like, I think 72 bucks or something, included this rubber, hard density kind of plastic rubber mount. I didn't price it, but if that was 70 with this, I'll bet you could buy this for $20 or so. The piece of aluminum to have it. They supply the aluminum at Sin Cut Sin, and they cut it out and ship it in the whole 9 yards. That was like 40 some dollars. So worst case scenario, I ended this about $70, about the same price as what that stainless one was. But I ended up with, again, one more reason to build things versus buying them is you get to customize them the way you want and to have the functionality that you want. So set the motor up here and see what it looks like. I think it looks pretty good. I mean, definitely plenty stout. I mean, the motor's moving in its rubber mounts, but if you watch the mount actually at the transom, there's zero movement there. So, let me grab a level. Kind of shoot a line across the So the bottom, you can't see the other end of my level, but it's right at the water line where it would come, the water would kind of skid off the bottom of the hole. I'm holding my level right there, and so the cavitation plate's maybe a half an inch above that line, so that should provide pretty good performance, especially even if you're going to reverse. The prop wash wouldn't hit the transom. And then, just like a traditional motor, You could tip that back up, and that's well above that plane, so that the motor won't drag in the lower unit will not drag in the water when you're on plane. And I could even create an alternate. There's enough room to pull this up even farther, so I could create an alternate or an additional prop and get this up even farther. But we'll try it out like that. So that'll wrap this episode up. I'm hoping to get back on some of the other projects, the gantry crane. I keep talking about that. I have all the materials. I just got to get going on it. And then I also have, while I was off that or not posting anything for those last couple months, I rounded up all those stuff to make a set of forks on a standard skid steer quick detach, which my tractor has that style of quick detach. So I'm going to build a set of forks on a fork plate that are adjustable for the tractor. So those are 2 projects that are ready to go. I just got to find time to do it. So thanks for watching my content. If you like what you see, remember to subscribe, like, and comment when you have a chance. Thanks.